My name is Darja Orlova, and I'm really excited to be here today and to see you all, and looking forward to connect after the talks. And yeah, we will be speaking about the secret element of Flutter BuildContext. A couple of things about me. Short version of my name is actually Dasha, so this makes me name buddies with Dash, who we all know. I'm a Women Tech Makers ambassador and also a co-founder of the Bunny Search app. This is, of course, a Flutter app, which helps to search for cruelty-free brands. And the most important thing for today is I'm a Flutter developer, obviously, and a mobile tech lead at Chili. And Chili is an agency from Latvia, where I'm from. And what we do is we create apps for clients. So I do a lot of code review, and I see a lot of similar errors done by developers. And I realized that a lot of them are because they don't understand how exactly BuildContext works. And I think this is because Flutter is so easy to start working with, start to be productive like from day one. You create an app and you go forward, that it's easy to overlook some base concepts. And further down the road, you encounter errors and it's much harder to debug. So in order to make the debugging easier and actually preventing those errors, today I want to talk about BuildContext. Okay, so agenda for today is how does Flutter work, how does it render widgets, and how those widgets are connected to the element. Finally, what is BuildContext and its relationship with all kinds of widgets. So, how does Flutter work? What do we know about Flutter? It's a cross-platform framework that can be run on different platforms, and it has been done before many times. And there can be several ways to do it. For example, show everything inside a web view. Probably not really good way. Another one is to translate framework-specific code into native components. And this is also probably not too performant. And the last way, the Flutter way, is rendering custom components, right? Except that in Flutter, they're called widgets. And in Flutter, everything is a widget, right? Okay, but what is a widget actually? And this is a question to which we will be returning today several times. But a simple definition would be that a widget is a basic UI building block. And to confirm that everything is a widget in Flutter, we can see from the very first line of the Flutter code that we run is that the actual first class that we pass to Flutter is already a widget, and it becomes our widget tree root. So, how does Flutter render widgets? Today we will be talking about this super production ready app that consists of 2 containers and the text in between them. And let's take a look at the source code. So basically, this is a simple stateless widget, and we can see that it overrides only one method called build. So if we take a closer look at the build method, we see that its return type is a widget, right? But what is a widget? Then we go to the source code of the widget class, and we see that it's an abstract class that doesn't extend anything, which makes it the base class. And then if we look further, we can see that stateless widget, stateful widget, inherited widget, and so on, they all extend widget, which means that from the build method, we can return any type of widget. All right, cool. And when is this method called? Well, it's called by the framework itself when the first time your widget is inserted into the widget tree or whenever it needs to rebuild the whole tree. And the important thing is that it can be called up to 120 times per second based on the refresh rate of your device, which means that you have 8 milliseconds to run the whole build method of your app without losing frames. Because if frames drop, UI will stutter and users will write really bad reviews that your app is laggy, and we don't want that. So it has to be performant, right? And the last thing that we see is that we pass BuildContext as a parameter, but we will return to that a bit later. Up to this point, we have only seen and actually told the Flutter what to draw, like draw text, draw container, and so on. But we haven't thought about how to draw it. No methods that tell like move X here and do this there. And when we start to dig deeper and try to answer this question, we understand that everything is a widget is only partially true. because there's many more elements and other things to that. Here's a very accurate meme by Chatai. And yeah, go check out his profile because he has also very great articles. Just a reminder what we're working with. This is how our app looks like. And if we represent it like a widget tree, small disclaimer here, this in general and the talks simplifies some things. It doesn't change anything for the understanding of the concept, but I have to make the disclaimer. So basically, this is how our current app widget tree looks like. We have material app as widget tree root, and then static homepage, column, container, text, and container. So let's zoom in and take a look at how does actually Flutter render one of the widgets, text. So we see that text is just a stateless widget with just a build method. We already know what this is. The interesting part is that it returns a rich text. So let's take a look at what is rich text. I hope the code can be seen, but I'll read it just in case. So we see that class rich text extends multi-child render object widget, which is a very complicated parent. And instead of build method, it doesn't have a build method. It has two new methods for us: create render object and update render object. So this is also a widget, but it doesn't have build method, and it has something to do with the render object, right? So let's recap. Oh, yeah, what I wanted to say is that if you take a look at container, you will find a similar story with it returning you a colored box in our case. So let's recap what we're trying to understand here. Up to this point, we have only extended stateless widget and used the widgets given to us by the framework. And we have arranged them, composed them into multi-part widgets, but haven't done anything to actually render the widgets on the screen. And here comes the only important takeaway that we need for today about render objects, is that every widget that can actually be painted and not just composed has to extend a render object widget, which in turn deals with render objects. So we won't be talking about render objects today because I think we're talking about build context, but we will get to this. But you need to remember that, if doesn't matter how much you compose your tree, in the end, the leaf nodes will always extend render object widget. Okay, so we have discussed two types of widget: composing widget, which are usually stateless or stateful widget and override build method, and rendering widgets, which are ultimately extend render object widget, but usually through one of the following subclasses. So it's either a single child render object widget, for example, colored box, multi-child render object widget, for example, column, or a leaf child render object widget, for example, error widget, and the only thing that they're different about is how many children they can handle. Okay, so now let's take a look at the widget tree from the perspective of their parents. I have divided those into two colors. For those whose parents are component widgets, they're blue, and for those who are render widgets, they are orange. So we see that leaves are orange, render object widgets, and everything is connected. But there is one thing that we also need to remember about widgets. If we go take a look at the source code, we see the annotation immutable, and this means that widgets are immutable. The properties are final. You can't change anything after you create a widget, and if you want a new one, you need to create a new instance. So every time your build method is called, you literally create a tree of new widgets. So yeah. And then we have a render object tree with mutable render objects, and half of the connections with the widgets are lost. So it kind of doesn't make sense. Like, where did the other widget go? How is this connected? We are supplying new widget every time the build method is called, yet Flutter is performant and it somehow mutates the render objects accordingly. That's when the element comes in. So element is third pillar of the Flutter trees, and it's crucial to understand what is element in order to understand build context. Because element is the connecting element of the mutable render objects and immutable widgets. So let's take a look again at what are we looking at stateless widgets class. And we see that it has two methods, build method that we have already seen, nothing new for us, and another method called create element, which returns a stateless element. And if we take a look at the actual widget, the base widget class, we also see that it has a create element method. So it probably is something fundamental. Okay, let's take a look at what exactly is stateless element. And I'm really sorry for the highlights. I was expecting higher contrast, so I'll be reading aloud. But yeah, sorry. So class stateless element extends component elements, but what we care about is the comment on top. It says that this is an element that uses stateless widget as its configuration. So to understand, elements are mutable and their life cycle is much longer than the widgets. So they're not created every time the build method is called, but widgets are. And widgets is just like a data class that's passed to the stateless element as its configuration. And yeah, continuing on that, let's return to our widget class. We have seen the create elements method, we know it. And there's a new method that we haven't seen before, and it's called canUpdate. And it accepts two parameters, two widgets, old widget and new widget. And it returns true if the widget runtime types are the same. So for example, text equals text, and if their keys are the same. We won't be talking about keys today. I encourage you to check out this topic if you haven't before, but yeah, in our case, the keys will always be null, so we will only fall back to the runtime type. So if the runtime type is the same, then the widget says that it can update itself. What does it mean? So let's take a look at the flow. The first time that the build method of the widget gets called, we check if it was the first creation insertion of the widget into the widget tree. And okay, yes, Enzo is not happy about elements. Okay, so yes, it was the first time of inserting this into the widget tree. And what happens here, I'm really sorry about the highlights, but basically what you need to know from this slide is that in the constructor of the element, we pass the widget, and the only thing that happens here is we just assign the widget as an internal field. So basically, widget is just a field of the element, internal field that the element has access to. You will understand in a second why it's important. But what if this wasn't the first insertion, right? Then the widgets that get inserted get called the canUpdate method, and let's say that it returns true, we canUpdate. Then, highlights. The update method of the element is called, and the only thing that it does in here is that it assigns the new widget that got passed to it to that previous widget field. See, we have discarded the old widget, it's gone, we don't know about it anymore. We have created a new widget, assigned it, and all of this time the element is staying the same. Just the widgets are changed. And the same happens with the render object. Like render object is updated, and if there are any changes, it also repaints. Okay, going back to our Flutter trees. Now everything is connected. We see this time not the parent widget, but the element, but they're like the same because each kind of widget has its own kind of element. And this time, render object elements have a render object, component element don't have render object, yet everything is connected and nothing is lost, and widgets can be supplied on every call of the build method, and it will still retain its state. Okay, cool. Finally, what is BuildContext? Well, the first time that I have shown you the source code of the elements, I have left out one thing, and now it's your time to tell me whether you can spot it. So yeah, basically what I have left out is that the abstract class element actually implements BuildContext. So the element is the BuildContext. It is something that is responsible for maintaining the state of your widget tree. And if we take a look inside the BuildContext class, was I speaking into microphone all this time? I hope so. Okay, so if we take a look at the BuildContext class, we see that it's also an abstract class. It has field called widget, which also once again says that this is the current configuration of the element that is this BuildContext. It has a method findRenderObject, and then it has a bunch of methods, scary looking methods with words like depend, find ancestor, and so on the BuildContext. We don't need to worry about them right now, so yeah, just note that they exist. And returning back to the fact that BuildContext was passed as a parameter to our main function build, we can see then in the element, this is the same for other types of element, but since we're speaking about stateless elements, for stateful element, basically it has its own internal build method, and when that is called, it takes its widget field, it calls build on it, and passes itself into this build method. And this is how we get the BuildContext that we get in our build method, which we then use to access all kinds of other widgets. So this is how it's all connected. What you see as a developer is BuildContext, but actually under the hood, it's the element. And the most common error types related to BuildContext, from my experience, are either related to Lifecycle, so it's been used too early or too late, or related to the position in the tree, so actually used too high or too low, or a combination of both. So, the scary ones, the ancestors, dependents, and inherited widget. If you have used Flutter for at least a little, you have probably encountered the pattern called the .ofContext methods, and this is how we access such widgets as theme, for example, which we have already talked about today, navigator, scaffold, media query, and so on. And I split them into two kind of parts. Those are ancestors and those are dependents. And let's take a look at ancestors. So here's a very simple looking app, right? There's nothing, just a text button in the center. And on the click of this text button, we try to access scaffold and show a bottom sheet, right? We access the scaffold via the .of method and pass it the context. And what happens when we run this app and click the button? An error happens. An error that says scaffold.of called with a context that does not contain a scaffold. All right, we really did not specify any scaffolds in this widget tree, so it kind of makes sense where it's going to look for a scaffold. Let's do this. Let's wrap this whole center thing into a scaffold. Now it should work, right? We run the code, we press the button, and we get the same error, right? What is going on in here? Why is that happening? We can see that there is a scaffold in our widget tree, but yet it still does not find it. Then let's take a look what's going on inside of the scaffold.of method. So we take a look and we find that what it tries to do is access via context scary looking method called find ancestor state of type and passes it the type. So what it does, it takes the context. Because context is your location in the widget tree, it tries to find an ancestor of this type. Well, the name says it all. But in our case, even though it visually seems like scaffold is on top of our widget, so it should be this like a normal, it should find scaffold as an ancestor. In fact, we use the context passed to this page, meaning that the scaffold and everything inside this build method will be like underneath. So there's no scaffold on top of, on top of this widget. So if we want to visualize, this looks like this. We have a static homepage which has its context, and then we only have material app. How do we fix this? Well, first option is to introduce a builder widget. It's used mostly for those cases when you need to introduce a context on another level. So what we do, we introduce builder, it introduces another context, and this time everything works correctly and the scaffold can be found. But if you don't want to use this kind of hacky method, but then you can split your widgets extract into your own custom widgets and use that and use its context. But then you need to be sure that there is a scaffold in the parent of the widget that you're using. All right, now let's take a look at the other part, the other type of function widgets that are called using this pattern. So you have all probably used media query of context, for example, to get the view insets bottom to like calculate the space on top of the keyboard. If you have done this, you also note that this is the only thing that you access. Like you take the number, you calculate the space that you need, you draw whatever you need to draw, and whenever something happens on the screen, for example, a keyboard pops up, it updates automatically. Like you don't need to use any listeners, nothing like that. Just access it this way. So let's take a look inside of media query and to understand how does this happen. So first time we see that class media query extends inherited widget. This is a new type of widget for us today. My highlights. The method that we have already seen many times, create element, it creates inherited elements. And also, this will be better. There's a bool that's called update should notify, which accepts an old widget. And we can assume that it compares the current widget with the old widget, and if there are any changes, then it notifies someone who wants an update, right? But how do I subscribe to something to get those updates? Well, when you access media query via the .of method, look what's going on under the hood. We again take our context. We call depend on inherited widget of exact type method of the context, and here's what happens. First of all, the same way as it was with scaffold, it looks up the media query in the widget tree, and if it doesn't find one, then it throws an error. We have already seen this. But what also going under the hood in this method is that besides just looking up, it adds the caller like the widget that will call this method into internal set of dependents. And whenever something in this inherited widget in media query changes, it notifies all of the dependents of those changes so that they can perform a coordinate action, which is usually rebuild. All right. And you have listened to the previous talk by Paul, so you will all reply correctly to this task. We have, again, a very simple homepage, which wraps several themes and shows a color text in the middle. And the question is, what color will be the color text? Green, pink, or standard blue, maybe? Anyone want to answer? Okay, correct. So you will probably win the quiz. So yes, it will be the pink, but I wanted to demonstrate this in order for you to understand that there can be problems and cases when you access something via the context and you get wrong widget, not what you were expecting. And this might be what is causing this issue. All right, the fun part. So in order to understand last type of errors related to build context, we need to previously understand the stateless element lifecycle. And we have three actors. We have the framework, the Flutter framework itself. We have a stateless widget, and we have a stateless element, which is also build context. So whenever I say element or build context, they usually mean the same thing because they are the same thing. And we take a look at the widget field of the element and the lifecycle state of the element. All right, so the very first time that your stateless widget gets inserted into the widget tree, we call the constructor of the stateless widget. And under the hood, as we have seen, it calls the create element function, which returns an element to the framework. And this is the important part. This is how framework understands that this widget and its element are ready to work with. It calls the mount method of the stateless element. This is when the lifecycle state changes from initial to active, and this is the first time when the build method is called and the first time you see your widget on the screen. So mount is the important method right here, because if you do anything before mount, then you will have problems. Okay, sometimes later someone calls rebuild of this widget. The framework checks the can update widget method that we have seen previously, and for example, our runtime types are the same, keys are the same, so it's true. The framework then calls the update method of the stateless element. It changes its pointer to a different widget, but the element itself is not recreated. Nothing gets changed there except the pointer to the widget. So the widget, the element is in the same place. All right, but next time someone calls a rebuild, this time canUpdate widget returns false. So the framework calls a deactivate method of the element. We don't care about that. But what we do care about is the unmount method, because at this point, the pointer to the widget becomes null, and the element's lifecycle state becomes defunct. And it is an error to access element context at this point, because as I said, the lifecycle state is defunct, and you will get errors. So another very popular, like I've seen this many times, error is BuildContext accessed in async gaps. So what can happen in here? So we have the counter text. It's just a gesture detector that on tap awaits a future and then shows a snack bar, right? So what we do is we await a future. So sometime later, when this future completes, everything that is written under it will also try to execute. But at this point, your widget could have been already rebuilt or completely removed from the tree, yet you have pertained the pointer to the context. You try to call it the show snack bar and unhandled exception. Looking up a deactivated widget ancestor isn't safe. At this point, the state of the widget element tree is no longer stable. So don't do this. Be very mindful of this error because it can not always show up immediately. And how you can handle this is enable the use BuildContext synchronously lint. And starting from Flutter 3.7, you can, in the stable branch, you can check context.mounted before accessing context. And before you tell me that you have already checked the mounted check many times, before Flutter 3.7, it wasn't on the context, it was on the state of the stateful widget. From 3.7, it's available even for stateless widgets. All right, so the last widget that we haven't seen the relationship with BuildContext is a very interesting one because you can catch all of the errors here. So just a reminder how a usual stateful widget looks like. We extend a stateful widget, and it also has a state that we also extend. Okay, cool. And if we take a look at the stateful widget's source code, we see that it extends a widget. We have already seen the create elements many times, and we see a new function called create state, which returns a state. And this is the same method that we override when we create the stateful widget for class. But what is interesting here is if we take a look at the stateful elements, we see that the stateful element has also a field called state, and this is actually the constructor of the stateful element is when the state gets created. Like the first time a stateful widget gets created, the first time its state is also created. And the state of the state and element, meaning the context, are bound for life. So state and BuildContext, one life forever, so they're together. And let's take a look now at the lifecycle of the state, because it is really important in terms of using BuildContext. The first time that your stateful widget gets created, the framework calls the initState methods. This is called only once per lifecycle. And if you access a widget, for example, media query or theme, so any widgets that can get updated at some point here to calculate some properties, then you won't get the updates later on. Because I'll continue with the next one. So to understand this, did change dependencies, another lifecycle method of the state is called always after initState, and every time inherited widget changes. So if you have subscribed to an inherited widget, this is the method that it gets called. And in here, it's safe to use like theme and media query and so on to calculate anything that you need, because if anything changes there, you will get the update. The init state won't be called again. That's why you can't subscribe to changes there. Build method is called every time after did change dependencies, did update widget, and set state. So this means also that you don't need to call set state and did change dependencies and did update widget. And in here, it's also safe to access media query, theme, and so on, the widgets that you need updates, because it will always be called after did change dependencies, so it's safe. Then there is did update widget, which gets called every time the widget has changed. So in case you need to do any recalculations based on the parameter passed to the stateful widget itself. Set state called by the developer to trigger rebuild, nothing interesting here. And dispose, which is called by the framework, and this is the same as with stateless widget and its element. Accessing context and state after this method is dangerous and it will result in errors, so don't do that. All right, so here's a quick recap of the widget types that we have overviewed today. Basically, they can be divided in different categories such as component, proxy, and render. They all have their own corresponding elements. Most of the time, you'll be using stateless widget and stateful widget, more rarely sometimes inherited widget, and even more rarely render object widget. I still haven't actually extended it to this day. Maybe I'm a bad developer, who knows. But yeah, the function of the component element is to compose widgets, of inherited to pass data down the tree, and of the render object is to render. All right, and just a reminder, errors related to build context, you're either accessing it too early, too late, too high, too low, or several things at the same time. Thanks. You can read more in my article for Code Magic. It has even more schemes and diagrams and information if you are into that, and also links to very good articles and talks. And connect with me on Twitter or GitHub.